Hi, this is Shailaja. I am the mentor of chemical sciences of the CSIR net. I'm going to explain about Lewis diagram and resonance in this particular video. First, we will discuss about the Lewis diagram, and then we will discuss about rules of the Lewis diagram. Lewis diagrams are nice ways of visualizing how the atoms in a molecule are bonded to each other. So let us take a small example, then we will come up with some rules later for drawing the Lewis diagram. So the example is that silicon tetrafluoride. Tetrafluoride means 4 fluorines. So first let us think about how many total valence electrons are involved in silicon tetrafluoride. That means how many valence electrons does a silicon have, and then how many valence electrons does each of the fluorine. So let us get out the periodic table of elements, and then you can see here that silicon its outer shell is third shell, and in the third shell it has 4 valence electrons. So silicon has 4 valence electrons, and fluorine, this is our fluorine in the periodic table, and the fluorine, its outer shell is the second shell, and in the outer shell it has 7 electrons. So each of fluorine has 7 valence electron, silicon has 5 valence electron. But we have 4 fluorines. So fluorine has 7. So 4 into 7 valence electron, that is equal to 28. And silicon has 4 valence electrons. So total 28 plus 4, so that is equal to total valence electron 32. Now for our simplicity, we will just take single bonds between the silicon and each fluorine. That is this particular diagram. So between silicon and fluorine, the bond is covalent bond. And this line represents that 2 electrons. So this is of 2 electron, this is of 2 electron, this is of 2 electron, and this is of the 2 electron. Then why silicon is at the center? That we aware of that. The silicon comparing to the fluorine is the least electronegative property. So whatever the element, the least electronegative property, that must be at the central atom, and the remaining on the outer side. So that is of the reason silicon is in the center. Now, as per octet rule, let us check each fluorine total about the total number of electrons. So already every fluorine has 7 electron. And now if you check with all the electrons, including which is in participated in the bond. So total number of electrons now it is 8. So similar you check for the other fluorines. This is the other one. 7 already there in the fluorine, and which is participated in the bond, take that also. Then total again 8. So it is satisfied by the octet rule by each fluorine. Now let us check the rules for drawing the Lewis diagram. First, we have to find the total number of valence electrons. In our example, silicon tetrafluoride, total valence electron, 4 valence electron in silicon, 7 valence electrons in fluorine, but 4 fluorines are there. So that is 7 into 4. So that is total is equal to 32. So that we have to calculate. So that is called total valence electrons in our example 32. Add electron for every negative charge. Subtract an electron for every positive charge. In the silicon tetrafluoride, electron for every fluorine. So every fluorine, fluorine is the every negative charge, that is the more electronegative element atom. So for that, the adding of an electron, and subtract an electron for every positive charge. So in this example, in the example of silicon tetrafluoride, so silicon is going to be a positive charge. So the electron is going to subtract from that. So that is the meaning of this point. And the second rule is central atom. Central atom is, in our example, silicon, because it is the least electronegative comparing the fluorine. So we'll take the silicon as a central atom and draw the bonds, and then adding of the fluorine about drawing the bonds between fluorine and silicon. Here silicon, each valence electron of the silicon and one of the valence electron from the fluorine participating in the covalent bond. So that is this. And next, assign the leftover electrons to the terminal atom. Fluorine, one of the electron already participated in the covalent bond with the silicon. So fluorine finally contains the 6 valence electrons. So that is 6 valence electron need to be assigned for the fluorine. If any necessary, assign any leftover electron to the central atom. So any electrons left over after assigning to the fluorine, to the fluorine means terminal atom in our silicon tetrafluoride. No, we don't have in this example. So not necessary to add any electron to central atom. So first we'll again repeat with silicon tetrafluoride, the same points. Silicon tetrafluoride. Find total valence electrons. That is 32 number, because silicon has 4, fluorine has 7, total 4 fluorines, 4 into 7, 28, 28 plus 4, 32. That is this particular point. And beside a central atom, that is a silicon tetrafluoride. In the silicon tetrafluoride, silicon is the least electronegative. And drawing the bonds between silicon and the 4 fluorines. So we take 4 fluorine and then we draw the lines between fluorines and the silicon. Now here, subtract electrons used for the total in step 1. Step 1, how many electrons used? Adding electron for every, that is fluorine valence electrons are 7. And we are adding 1 electron as per the octet rule for fluorine. That is add an electron for every negative, subtract an electron for every positive. That is silicon 4 valences. Each valence electron is participating in the covalent bond. So that is the following the rule as per the step 1. So now 4 already participated from the silicon, and fluorine, one of the valence participated with the silicon. So how many electrons left on the fluorine? Each fluorine, 6 electrons. So 1, 2, 3, 4, 5, 6. Similar 1, 2, 3, 4, 5, 6. Like that we can imagine for the remaining. So 6 into 4, 6 into 4, 24. 24 electrons, and each covalent bond 2 electron, 2 into total covalent bonds are 4, so 2 into 4, 8, and 24 plus 8, it is again 32. So initially we calculated how many valence, and after a bonding of the silicon and fluorine, and we got the result 32. So we don't have any leftover electrons. If any leftover electrons after covalent bond, that need to be added to the central atom. But in this example, we don't have any electrons left over on the fluorine side. So that is all about the Lewis diagram and the rules following for drawing the fluids. Next, resonance. Resonance is easy to understand from this particular example. We are taking example here, nitrate anion. Nitrate anion It has 1 nitrogen and 3 oxygen, and with the negative charge. This is negative charge. So first, if you check for the total valence electrons, for nitrogen, 5 valence electron, and oxygen, each oxygen, total 3 oxygens, each oxygen has 6 valence, but 6 into 3 total of 3 oxygens, total 18 valence electrons for the all the 3 oxygen. So total number of valence for nitrate anion, 5 plus 18 plus 1. This 5 is for the nitrogen, 18 is for the 3 oxygens, and 1 is for the negative and negative charge. So total, that is the calculation, 24, it will be 24. Total valence electrons for nitrate anion is 24, including the negative charge. So this is the Lewis diagram, Lewis structure, and this Lewis structure, as per the rules discussed previously, a negative charge also given because of the nitrate has a negative charge, one negative charge. But here we need to check the full octet rule between nitrogen and oxygen, and one of the bonds have different energy than other oxygen. Here each oxygen is with the nitrogen bond. Here it is one bond, here also a one bond, but here between nitrogen and oxygen is given 2 bonds. We have total 8 valence electrons around each of oxygen, that we can understand easily. Here 6 to the oxygen, and this bond represents 2, 6 plus 2, 8. So 8 octet rule satisfied. And for this oxygen also 6 plus a bond represents 2 electron. So total 8. It is also satisfied octet rule. If you check here, 4 bonds visible on oxygen. Here 2 bonds again. These 4 valence electrons visible, and 2 bonds visible here, and each bond represents the 2 electron. So that is 2 plus 2, 4, and 4 plus 4, it is 8. So again, octet rule satisfied between this oxygen and the nitrogen. But it will contain generally, I mean, total nitrate anion contain in this case, one longer bond, one shorter bond. But that is not the real world case. If you see, all the bonds actually have the same length, and they have actually have the same energy. Also, the question is that why equal energy between any bond here between nitrogen to this oxygen or nitrogen to this oxygen? It's the same energy. Why is that? Here you can easily understand that when I took a lone pair to create this particular covalent bond, I could have done it with the top oxygen. That is this diagram, top oxygen, nitrogen to top oxygen. I could have done it with bottom left, that is this between nitrogen and oxygen bottom left, or another probability, I could have done it with bottom right oxygen. So this bond is not onto the top of oxygen. It could be on the this side or this side or this side. So there is 3 actual valid Lewis structures for the nitrate anion. So that is called resonance. So this is the example of resonance. And also we put arrow mark between one Lewis structure to the another structure. Nitrate anion could be like this, could be like this, or could be like this. There are 3 possibilities for the Lewis structure for nitrate anion. So this is the example for the resonance. Thank you for watching, and we will discuss another topic in the next video.